I'm back with the solution to the homework problem. So this is page 272, 18A. This is the solution to 18A, so I'll pause. And you should have checked the solution, and if you need to see how to do that, you can hang on here. Here is 18B. 18C, and 18D, and the answer is 220. So I'm going to go through how to do all of these now. Just take a look at the video, what you need for yourself. No need to watch the whole video. Okay, so for 18A, the question says, if a gas at a pressure of 1.2 atmosphere and at a temperature of 22.0 degrees Celsius occupies 0.350 liters, what pressure will hold the same sample of gas in a volume of a 0.050 liters if the temperature of the gas increases to 25 degrees Celsius? There's a lot of numbers there, isn't there? Okay, but let's just break it down here. Let's break it down. So we need P1, V1, and T1. Going through the problem, reading again, my original pressure is 1.2 atmospheres. The original volume is 0.350 liters. And the temperature is 22.0 degrees Celsius. Converting that to Kelvin, 295 Kelvin. Now this is an absolute number, but I only have two significant digits up here, so I'm not going to conserve that decimal digit. It's just not necessary. So P2 is what I am after. My final volume is 0.050 liters, and my final temperature is 25 degrees Celsius. Adding 273 to that, I get 298 K. So I have all of my quantities. My equation plug the numbers into my equation. Over on the other side. Okay, now I need to cross multiply to start solving for P2.
There's a milk jug out there. You want that?
Sure, Brian. Then I have to divide both sides by these two numbers to get P2 by itself. Canceling out units, I'm left with atmospheres, which I'm after because it's pressure. So P2, when I multiply across the top, divide that by what's on the bottom, I end up with 8.5 atmospheres is the answer. Now, 2 significant digits because I have 2 significant digits right here. The rest are, well, I have 2 here as well. The rest are 3. Okay, moving on to 18B. I have a lot of papers to juggle here. Reading the problem. A 15.04 liter of volume of gas at 700 torr of pressure has a temperature of 35 degrees Celsius. What will its temperature be if the pressure increases to 735 torr and the volume increases to 23.8 liters? So I write down all of the quantities I am given in the problem. The first one is 700 torr for the pressure that I start out with. My initial volume is 15.04 liters. And my initial temperature is 35 degrees Celsius. Convert that to Kelvin, I get 308 Kelvin. P2, V2, and T2. I'm looking for temperature in this case. My final pressure is 735 torr. And my final volume is 23.8 liters. So I write down my equation. And I plug in my numbers. Okay, this time I'm looking for T2 down here, but I'm still going to cross multiply. So this time, this is what my cross multiplication looks like. Don't really need parentheses for T2. So I multiply here, then I multiply here. Now I have to divide both sides by these two numbers to get T2 by itself. Okay, so all of these cancel out. Whoops, I can't cancel out kelvins because there aren't any on the bottom. But I can cancel out torrs and liters and be left with kelvins, which I'm after temperature, so T2, when I multiply across the top, divide that by what is on the bottom, I get 512 Kelvin. And looking at all my numbers, 3 significant digits here, so I have to end up with 3 here because this is 3 and 4 significant digits. So, well, actually I should look over here, but 3 is the least number. So 512 Kelvin. Okay, moving on to C. reading the problem. A 40 milliliter sample of hydrogen is collected by water displacement at a temperature of 20 degrees Celsius. The barometer reads 751 torr. What is the volume of dry hydrogen at STP? So this is over water displacement, so we have to do that extra step with the pressure with Dalton's law of partial pressures. So P1, V1, T1. My original pressure is 751 torr. But because this is water displacement, I know that this is the pressure of the hydrogen and the pressure of the water combined. Oh, I just realized that I have an H instead of a P in my original answer. That's just like a little copy error thing. Sorry about that. Thinking ahead to the water and writing that down. I have to subtract the vapor pressure of the water from that. Now, remember, I get this from my book, page 256. But I need to know my temperature. My temperature is 20 degrees Celsius. So here, 20, I'm in torr, so I have to subtract 17.535. When I do that, I get 733 torr. And this is the pressure of just my hydrogen. My initial volume is 40. And here I have to add 273 to convert to Kelvin. So I had to convert my pressure and my temperature here. Now down here, P2, V2, and T2. I think they are saying at STP. So I'm trying to find volume. My pressure is 760 torr. My temperature, 273 K. So let's go ahead and write down our equation. Plug in the numbers. Now I have to plug in my adjusted pressure here. That up before I forget. Okay, so cross multiply. Divide each side by these two numbers because I want to get V2 by itself. Okay, so V2 equals multiply across the top, divide that by what is on the bottom when I multiply those two numbers together. And V2 is 35.9 milliliters. 3 significant digits because all of my numbers up here are 3 significant digits. Okay, and last but not least here, well, not quite, okay. At least for this problem, we're almost done. So 18D. Now we have problem 20, but that's pretty short. 18D, a sample of nitrogen gas at 16 degrees Celsius and 760 torr has a volume of 2.6 liters. What is the volume of the gas at STP? So no water displacement here, yay! Just straightforward combined gas law. So my initial pressure is 760 torr, volume 2.60 liters, and temperature 16 degrees Celsius. Convert that to Kelvin, 289 K. My final pressures is 760 torr because this is a STP. Volume is what I'm trying to find. And temperature 273 K because it is STP. All right, write down my equation. Now, right here, I could realize that these pressures are both the same. And so I could just do V1 over T1 times V2 over T2. I'm going to plug in the numbers though just to show you how they cancel, just because they're there. So I plug in my numbers. Cross multiply. Divide both sides by these two numbers to get V2 by itself. All of those cancel out, leaving V2 by itself. Now my units cancel, this whole quantity here cancels out, so I'm gonna cross that out. K cancels out, I'm left with liters for volume. So V2 equals, I'm gonna multiply these together, divide by 289, and when I do that, I get 2.46 liters. 2.46 liters. Okay, and for 20, this just deals with partial pressures. 20A. So they give me a bunch of information. Most of it's pretty irrelevant. We really do not need the equation for this. A technician produced H2 gas by reacting zinc with sulfuric acid. The reaction was, and you're given the reaction, he collected the hydrogen in a flask by water displacement. atmospheric pressure was 737.2 torr, and room temperature was 25 degrees Celsius. So A, what was the vapor pressure of the water in the flask? That is just from our chart. We're given a temperature of 25 degrees. So I look on my chart, 25, and I want torr. So it's 23.756 torr is the vapor pressure. So I just write that down. Okay, so that is the answer. This is from table 10-4, page 256. For B, what was the pressure of the hydrogen in the flask? So I take my pressure that they give me, 737.2 torr, because that's the pressure of the hydrogen and the water combined. So this is pressure hydrogen plus pressure water. I subtract this number here, 23.756 torr, because this is the pressure, partial pressure of the water, and I get 713.4 torr. This is the pressure of the hydrogen alone. For C, they say, suppose that a leak in the gas collection tubes accidentally let a small amount of air into the flask. The unwanted air exerts 25.2 torr pressure in the flask. How much pressure is the H2 exerting in the flask? So now they tell us that this just isn't hydrogen gas. This is hydrogen and a little bit of air. So I'm going to transfer this number down here, 713.4 torr. This is the pressure of the hydrogen plus the pressure of some air. I want to subtract the pressure of the air, which they give me, which is 25.2 torr. When I subtract that out, I get 608.2 torr, which is the pressure of the hydrogen by itself. Now, looking at these numbers, you're probably wondering, how do I get my significant digits? Well, when we do subtraction, remember we go with place value, the lowest place value. So here it's the 10th place, so I have 10th place here. And tenths, tenths, tenths. So that's how I do my significant digits for these numbers. Okay, I will be back tomorrow with the next section.